All right. Hello, everyone. Welcome to our online lecture. Let me know if you can hear me. Can you see me? Can you see the screen change? There's no echo. Things are going well. Excellent. How exciting. Oh, amazing. We've started a lot better than yesterday, so that's something to be proud of, I think. Amazing. Don't say everything is working. We don't want to jinx it. So let's just try and let's just hope that the internet holds out today and this stream will just be seamless. All right. Welcome back, everyone. I didn't set up that camera very well, did I? You can barely, doesn't matter. You don't really need to see me as much as you need to see everything else that's going on. Okay, so let's start lecture 2. How exciting. All right, so yesterday we talked about the tech issues at UNSW. It was an extra special welcome to all of you. Then we got that lovely email that the internet is down. And then we got that lovely email today again that the internet is down. So that was the reason that some of our issues kind of happened. We also did some welcome and introductions after that beautiful 38 minutes of tech issues. We did course admin. We talked about how 1511 works and how you can get help, the best ways to approach learning programming. And then we did our first little program as well. And the first little program, just hello world, as it always is. And I don't know, it was very exciting. Maybe you were not as excited, but it was kind of exciting. So that, I think, went well, and maybe we'll see what we can do today. We're going to do a lot more today. So today we're going to learn about some variables. We're going to learn how we store information in C, and then we're going to talk about constants, and then we are going to look at some of the maths operations in C, because there are some quirks and some really fun things that C does that just don't kind of make sense as much as they should. Is that camera all right, or is it just like a tiny little part of me? I don't know. Who cares? Who cares, right? I can see the chat. Good enough. All right, fantastic. So let's start. I don't know what to do with myself. Everything is working. I feel like there's no stress. This is just not the normal way that we like to operate. Live lecture code will be back where it was before as well, and you can find it on the website as well. And on the website, you just go to where it says lecture code, and then we can and then you can access whatever lecture code we do today, because we're going to do a lot more lecture code today than yesterday. Let's just quickly go over the little program that we wrote yesterday and what everything was in it, because we kind of rushed a little bit. Well, I rushed a little bit at the end to try and fit in as much as possible into that beautiful week 1. So over here with our slashes, we have a comment, and the comment is for human eyes only. That means that when you compile your program, it just skips over that. It's not instructions for the computer, it's instructions for the human that's reading this code. And it basically just says what the program is doing. It might say your name or any other details that are important. Then on line 7, we have this beautiful include stdio.h, and it is a standard C library. And what it does is it allows us to have access to some functions that give us some basic things that allow us to print out onto the terminal and to, as you will see later, scan things out from the terminal as well. So we need to include it basically for all programs that you will write. You will need to include this stdio.h, and you might start to include other libraries as we go forward in this course, as you learn more and you start using more things and doing more complex programs. So this hash include is a special thing in C, and then any standard library is always included with greater than and less than symbols. And then we get to our actual program. So from lines 9 to 12, we've got our actual program, and this program is called main, and that's where that's where C always starts reading. So it always starts at main. Even if you have a lot of things in there and a lot of different functions, it will always start reading at main. And if you remember, we talked a little bit about what this int means. It's an integer and it corresponds to this return 0 here. So something is being returned and this return is going to be an integer, and this integer in this case is 0. And it basically means that the program has run successfully with no issues. And you can see other numbers in here, right? Because it's returning an int, it can really return any int at all. And then we have our void in brackets, and that, as we said yesterday, basically just means nothing. So you're not giving the program anything to work with. It doesn't need anything, any inputs. It just kind of runs itself. And we will talk, I think, in week 5 and in week 6. Not in week 6, actually. We're not going to be talking in week 6. That you're going to be resting in week 6. But in week 5, maybe in week 7, we're going to talk about giving something to the main from the command line to take in. And that's going to be very exciting as well. Okay, and then on line 10, we print out something to the terminal. So we use this printf function, and we will talk more about functions next week. So don't worry about that. But just remember that printf prints something out to the terminal, and in this case we're only printing out text, right? So we're not printing out any variables, we're not printing out anything else. So the text that we print out is going to be enclosed in double quotation marks, and then you have this /n at the end, and what that /n does is it creates a new line. So if you remember, it just means that it goes to a new line. It's like you've pressed enter. And then the return 0. So keywords is this return 0, and you will see again in a few weeks about what it means, but for now just kind of go with the flow and remember that this is the structure of a basic program, well, a basic function rather. Okay, so how does a computer remember things? Okay, ones and zeros. So it's basically a big pile of on and off switches, not stitches. I hope the computer doesn't have any stitches, but it does have switches. So big pile of on and off switches, and we call these switches little bits, and it's the smallest possible unit in computing. So a bit is basically a choice between 1 and 0. Now we group these bits together, and so 8 bits are a byte, and then we can continue grouping on and on. And I saw in the forum someone asked, oh, what's the size of the program? Is that the size of the program? So that was kind of like, it's how we store things in memory and how we know how much of memory it has taken up. Okay, a little bit, and you will not need to kind of recite this back, but I think it's nice to know how memory is structured because it helps you to then understand what's going on afterwards. But you don't need to understand it completely right now, don't worry, but it will help you to understand where variables go and what they mean in the program as well. So when we execute code, we're using 2 important pieces of hardware at runtime, and the code is loaded into some fast data handlers, and those are your random access memory and the central processing unit. And the central processing unit is in charge. Sorry, I was trying to show you and also look at the chat at the same time as well, trying to do too much stuff. So the CPU is in charge of processing the instructions and performing the basic arithmetic that you program, and the RAM is responsible for keeping track of the data that is needed for actually executing the processes. So that includes your actual code instructions. As you can see, you've got your code down here, and also all your variables and any function calls that arise. And again, you will see what function calls mean when we learn more about functions next week. So today we're actually going to focus on the stack, not the heap, but in about week 7 we're going to move ourselves into the heap. And basically just think about it this way. The heap is disorganized, the stack is more organized, and we will learn more about it in a few weeks, okay? but you are currently sitting in the stack with all the variables that we're about to discuss, because we declare them and initialize them at the start, and they get given some space at the start of the program. Okay, so what is a variable? Okay, so what is a variable? I think everyone kind of knows what a variable is, probably has had to deal with variables in places like maths, and it kind of means a similar thing, really, in that a variable is something that varies throughout our program, and it's our way of asking the computer to remember something for us. Okay, so variable because it can change its value, and there is a certain number of bits that we use to represent something, and that comes into it when we have different types of our variables. You know, you can have an int or you can have something else, and we'll talk more about that as we go, and each one of them takes up a different amount of space. So we make a variable with a specific purpose in mind, as in we know how we're going to use it within our program, and so we know how much space it will take up when we make it, because we know what kind of variable we need. Okay, so we're going to start today with 3 types of variables, okay, and then we will build up our understanding of what else we're going to, use. So we're going to start out with an int, which is an integer, and you saw kind of like the start of int, and you saw it when we did int main, but used in a slightly different way, not as a variable, but as a return of a function. So we're going to use it as a variable in a few minutes. But basically an int is a whole number. So, and it can be negative or positive, but a whole number, no decimal places. Then we're going to look at a char, and a char is a single character. So things like letters of the alphabet are chars, but there are also other chars, and I'll talk about that when I actually talk about chars, so that it's not just a whole bunch of information overload for you. And then also a double, a floating point number. So that's your decimals that we're going to talk about. Someone's asked, there is no string. In C, strings are a little bit weird. Strings are actually arrays of characters. So we're only going to do strings in a little while. Okay, so there's no strings today, because strings are actually a weird thing in C. They're an array of characters. They're not on its own. Okay, so each one of these has a different number of bytes that are allocated in memory once the program is run, and we basically know how much space we need to run a program. So how are we going to name our variables? Are we going to do how you saw my desktop names things? Do you reckon test 1, test 2, test 3? Who's going to name their variables like that? I hope no one, by the way, but what do you reckon? Should we give variables nice names? It's really weird being not in the theater. Yeah. Towards the end of the term, you'll start seeing my desktop will just say exam 1, exam 2, exam 3, and it's also going to make no sense whatsoever. All right, so definitely we don't want to name it test 1, test 2, test 3. We want the names to be a quick description of what the variable is. And why do we want that, right? We want that for the humans that are reading. You know, the computer doesn't care what you name it, but we want it for the humans to be able to read our program. If I'm reading someone's program and the function name makes no sense and the variables make no sense, I don't really know what I'm looking at straight away. I really need to sit down and try and process what's actually going on there. But if I've got a program that's written with nice variable names, you know, where things are descriptive as to what they do, it makes it much easier for me as a human to interpret what's going on in a particular program. So we really want to name things, you know, answer, diameter, things like that, instead of A or B or test 1, test 2, test 3. We always use lowercase letters to start our variable names, and C is case sensitive, and that means that things like answer and answer with a capital are 2 different variables. You also cannot use some of the reserved words in C, which means things like return, int, double, your own names. You can't use the ones that C already uses. Now in 1511, we want to use snake case, and sometimes by accident you'll see me use camel case. I'm sorry, but use snake case for multiple words when you are doing your coding, and which means that you can split longer words with an underscore, so it makes, you know, more sense as opposed to just having it all in one sentence, which also doesn't make sense. Okay, so we do have a style guide in 1511, and there's a link to the style guide. So remember that we really do name our variables in ways that make it obvious what they're representing, and that is for the human that's reading your code. So someone can skim your code, know exactly what's going on and what you're trying to do. Well, broadly know exactly what you're trying to do. So follow the style guide. In the assignments, you have marks assigned for your style. And you know, if you follow the style, they're pretty easy marks to get. Someone's saying, what is a style guide? The style guide basically describes how we want you to write your code, in what way, how we want you to tab characters, how we want you to, you know, spell out your variables. It's basically a guide as to how to style your code. So not the actual code itself and the functionality of the code, but the way the code looks so that someone else can read it, and also so that you can debug it much easier, because it is really hard to find an error in code that's just all written, you know, justified to one side. None of the variables have any good names, so it's very, very difficult to actually do anything. Okay, let's talk about ints, and then we're going to do some lovely, lovely code. Okay, so an int is a whole number, and it's got no fractions or decimals. So it has to be, yeah, it's just a whole number, really. There's nothing that's hanging off on it. So most commonly uses 32 bits, which is also 4 bytes, but don't count on it, right? It's not always 32 bits. Who knows why it's not always 32 bits? Does anyone know in the chat why it's not always 32 bits? I think there's a slight delay on me speaking and you in the chat. Yeah, so it has to do with the architecture and what you're running on. So it's not always 32 bits. But if it is 32 bits, right, it gives us exactly 2 to the power of 32 different possible values. Now, whilst that is a very large value, it is not infinite, okay? There is a limit, right? You can reach it. And I do have some examples in these lecture slides of when those limits have been reached in real life, and the issues that have happened when they have overflowed. So the exact range is from that number, so minus 2 to the power of 31 to 2 to the power of 31, negative 1. Why do we subtract minus 1? Do you know? Who knows why we subtract minus 1? Yeah, well done. So it's because of the 0. We have to include the 0, and that means that we subtract 1 for that 0. Okay, fantastic. Let's talk a little bit about characters, and then we'll talk a little bit about doubles, and then we will get into some code. So characters, a single character in C, and the most wonderful thing, it can also be represented as an int, and that is because they're ASCII values. So I provided an image here, but actually it's easier to for me to just call it up on my computer and actually share the right screen. That would be nice too, wouldn't it? Okay, if we go to this screen, that was seamless. You know it. It was just a seamless transition. And we do ASCII and I'm going to do this -d for the decimal values only, so it doesn't give me more confusing stuff. So this is all of our beautiful chars, okay, right here. And there's a lot of really, you recognize probably the alphabet, that's easy enough to recognize, but then there's a lot of other things that are also chars, okay? So who knows, and some of them are quite, I don't want to say old-fashioned, I don't want to feel old. They're from the past. Let's go with that. Who knows what number 10 LF stands for? Anyone? Anyone? Who's Googling this? The /D command is to only give the decimal values. Lightfall, definitely not that. New line, exactly. It's a line feed from when you had a typewriter and you used to have to do a line feed when you wanted to move it to the other side. So really old school. That one, who knows what number 7 BEL is? I'm just picking my favorites, really. I love that one. Yay, someone's got a ding ding bell. It gives a little ding ding and a typewriter bell sound. Yes, very good. Although if you try and do it on these machines, it obviously will not do it because you are remotely connected. So yeah. Ibby, beautiful bell, well done, beautiful emoji. Amazing. So I don't know, those are some of my favorites. You will most often deal with the alphabet when you do chars in 1511. You won't really deal with you will not deal with the, I keep trying to highlight it in columns. You won't deal with these two columns most probably at all in 1511, but you know, just for funsies. Okay, so a single character is represented by an int as well, and that means that capital A is actually 65 as well, okay? And if you want to assign a character value, then you put it in single quotation marks. So let's switch back to the lecture slide, another seamless transition. Not that you can see part of the screen, I can see you can see a bit of me, which is probably not as exciting as seeing the screen. So single quotation marks just over here. And that says that it's a character and it's an ASCII value. So for a capital A, character is A in single quotation marks and the int stored is 65. So you use a char to declare a character, and then if you do, for example, and we'll talk about that in a second, if you assign it a little a, it will also assign 97 to it, which is the number of it. Okay, excellent. And let's look at doubles. Okay, so a double is called because it's double the size of an integer. So an integer is 4 bytes, and then a double is 8 bytes. And it's basically a floating point number, so it's your decimal. It means the floating point means that the decimal place can be anywhere in the number, and it's called a double because it takes up double the space of an int. So those are the three that we will start out using. Let's do some code. I think enough talking. Let's do some code. Okay, what should we do as our? What should we? Let me test you. First test. There we go. What do you think we should name this file that's going to demonstrate variables? What should we have the name of the file be? To have good style. That shouldn't have been in inverted commas. I'm actually serious about having good style. Someone's clearly read A.C. Someone's clearly seen my desktop. Yeah, something. Test 1, one of my favorites. Test 2, also my favorites. Something.c, yeah, amazing. All right, let's call it variables.c. How's that? Okay, I think those are almost all good suggestions. There are some trolling ones, which I appreciate. Okay, amazing. Let's do it. Okay, so first things first. Let's do our beautiful comment, probably even using the right way, slashes. Okay, and this program will demonstrate the use of variables in C. Fun. Didn't really need to do that. And it's week 1 and it's lecture 2, just so that you know what's going on. All right, what should I do next? I'm ready to start my program. What do you reckon I should do next? What should go on the next line of code? You know what? Yeah, and I will just go with that. I prefer light mode versus dark mode, and it is a sickness, and I know that people do not, but I cannot see the darkness of screens. I am sorry. Perhaps at one stage I will switch to a different dark. I know it's actually outrageous, but just tell me if you cannot see my light screen or if it's all right, and then we can. Okay, so I'm going to hash include, and then I'm going to include my standard input output library.h, and we are ready to go. So what I'm going to do now when I write programs for the next few weeks is I'm going to have a lot of comments in my programs, okay? And that's so that when you look back on these files, you know what's going on. Now, do not ever comment your code like that, because if you do too many comments, it makes your code very hard to read, okay? The reason I'm doing it is so that you can go back to it and you can look through it and then you know what's going on. So, okay, I'm just going to say this line includes this standard C library. Okay, amazing. Now, the next thing is we're going to have our main int main void. And remember, for the next few weeks, just go with the flow. Have it as your, just have it as kind of like a template, that kind of style. Okay. So int main void and return 0. Pring. Clearly, I feel like Pringles. I really do. Could really use a Pringle actually. Okay. So let's learn what we have to. Okay, someone's asked what void means. Void means nothing. Okay, as in it means nothing. It means we're not giving the program anything. It's got no inputs into it. Sometimes you would have seen, if you have looked online, they will leave it like this with nothing in the brackets. Don't do that. And the reason for not doing that is when you want to be really clear that nothing is included, it makes for much better code style as well. Okay, let's do it. Okay, and I can explain return 0 again. So return 0 is basically, we are saying that the function is going to return something here. I'm just kind of starting a functions lecture as well at this point. What do you reckon? So I'm saying I'm going to return an int here. What do you reckon if I wasn't returning anything? What would I write there? What do you reckon? Just take a guess. Yeah, I'm just going to say void if I'm not returning anything, right? Void means I've returned nothing, and there we go. Okay, so let's, Julia, yes, but we are in introductory programming, so we're teaching you certain things to do with style, which means that we are going to teach you things slightly differently until you move to more advanced courses. Okay, so in this case, we are going to have an int here. It means that we're going to return an int. So when we return an int, we've got to return something. We've got to use this keyword return. and then in our case, we've returned 0. When we return an int, we can return anything at all, okay? Any number at all. You could, you'll see some of our, especially in exams, we go crazy. We return 42 because I don't know if I'm too old or if, anyway, meaning of life, 42. But usually you will return a 0 if the program has run through beautifully with no issues, and then you'll return a 1 or something else if there are some issues. It's just kind of standard practice, but for now you're just going to focus on returning 0 and not even worrying about it for now. When we talk about functions, that's when we'll start to return a whole bunch of other things, okay? Okay, so when we have a variable, okay, we need to tell C that we want a variable, okay? And that's called declaring a variable. So if I declare a variable, okay, what I will do is I will say a few things. I will say, one, what is the type of variable, okay? And that can be, well, so far we've only learned 3, so it can be one of 3. It can be an int, a char, or a double. So let's start with an int just because it's the easiest one to start with. So I'm going to tell it I want a variable of type int, and then I'm going to name my variable, okay? I'm going to give it such a good name. It's not going to be something random. It's going to be, and I'm not very good at thinking up variable names. It's going to be something that makes amazing sense. Let's just call it number. What a great, and you finish with a semicolon. So that's called declaring a variable, right? You said what type of variable it is, int, and then you said the name of the variable is number. Now, if I want to initialize the variable, which means I'm going to give that variable a number, okay? Then what I will do is I will say number is equal to, and it's equal to 42, okay? So this looks nice, fantastic. I've declared, I've initialized. You don't have to do it in 2 lines. You can declare and initialize in 1 line as well. So I can do it all at once. Declare and initialize. Oh my gosh, it's like a riddle. Say it more than once. So I could do it. Let's do int number. It's starting. I'm starting to do the 1, 2 thing. I'm sorry. Okay. Number 2 is going to be 13. So in this case, what I've done is I've declared and initialized a variable all at once. And I did int again for the type of variable that I want. The name of the variable is number 2, and then I've assigned it a value. So note that I've used 1 equals sign, and that 1 equals sign is going to assign a value to my variable. Okay, so fantastic. We now know how to do a variable. We know how to declare it. We know how to initialize it, which means to give it its initial value. And then we can change it throughout the course of our program by basically saying whatever the name of the variable is and assigning it a different value. Okay, so how are we going to use this, right? Well, you can use it in all sorts of different ways in a program. You can you can do some maths, or we will do maths in a second, don't worry. But let's just see it printed out onto the terminal, because that's, something that we can do very quickly. So far what you've done is you have used printf to print something out to terminal. And it would have been something like this. You have not learned how to actually give it a value. But what's the point of just printing out string literals? What's the point of printing out just a text message? I want to be able to print out some sort of variable as well, because, when I go through my program, I change up my variables. I want to be able to print out their values at some point in time. So what I'm going to do is I'm going to use something called a format specifier. And what that's going to do is going to allow me to placehold a certain variable in there. So now my variable in this case is an int, which means that the format specifier I will use is a %d. Okay, so the %d, the % symbol is a symbol, and it's followed by some sort of characters to tell it what type of variable I'm actually trying to placehold for. So in this case, I'm doing %d, and that's because I want a number, right? An int. So if I've said to you, well, I haven't said to you, I've said to this program, I want to placehold a variable in here. I want to print out a variable. I need to let it know what kind of variable which variable I want to put in. So I've got a placehold, then I will put a comma, and I will write down which one I wanted to print out. So I'll write number. Let's print out number first, and let's see what it does. Okay, so let's save this. And that's really, Okay, so let's compile it. So DCC, and I'm going to compile. You know what? This file is now located in God knows where. It's not located where I want it to be. I'm going to have to move my file. Apologies. The next lot of commands, don't look at them. Don't worry about them. Where did I put it? I just put it, great. Okay, now let me. Okay, so there we are. We've got our variables. Let me make sure that you can see them as well. Okay, so you can see it as well. And let me clear my screen. Okay, we're ready to compile. Amazing. Okay, so if I'm going to compile it, DCC, my file name is variables.c, and I'm going to give it a name so it doesn't come out with a.out. Okay, so also my compiler's given me a warning, right? And it said, oh, you've got an unused variable. So what that means is I've declared and initialized a variable, number 2, but I haven't actually used it anywhere. Okay, so I can just push past it and ignore it, or I can comment it out before we're using it. I'm just going to ignore it for a second, and I'm going to run our variables program. And what it's going to do is it's going to print out the number is 42. So it's taken this placeholder and it's taken what I've said I want to be in that placeholder, which is number, and number is equal to 42, which means that it's going to print it out onto my terminal. Okay, I can also do more than one number on here. It doesn't matter. I can do more. I can do 3, 4, 5, 6 numbers, right? So I could say the second number, and then I'll do a %d again for my second number, and then in the order that they appear. So this number is going to correspond to my first placeholder, and my second placeholder is going to correspond to my second number. And let's say the second number is number 2. Okay, so, and let's save, and let's run it again. So I'll compile it again. And why do you think it's giving me that error? What do you think has happened? Who knows what's going on and why this error is given? Even though I've used the second variable now, why is it still giving me this error? Just calm down on the other format specifiers. We're about to do them. Don't rush. Take it easy. So I can put 2%Ds in same quotation marks, not even more. I did compile. I did save. It was saved. So you can see there's no black dot. I have saved it. But if you look up here, it is in a completely the wrong place, okay? So I'm still using something that's completely different. I've just saved a file and it's now in the wrong place, okay? So that's really what is wrong here. And you will have that happen as well to you. So, okay, this is now my right file because it's in the right location, okay? And that means now when I fix it over here, so I've got my first number is this, the second is, and I'll use another %d, and then over here in the same order, I'll do which order I want them in, so number and number 2. And let's save it. And let's compile it again. And so now it's going to compile with no problems, and I'm going to run it now. Okay, and now it's saying the first number is 42 and the second is 13. And the reason I made you, kind of try and guess what was wrong is because that is an error that we see a lot, okay? And sometimes when you're stressed with your assignments or your labs, we see that happen a lot. So so look out for that, where you're in the wrong place and you're doing your old code and it's all a bit of a disaster. Okay, so that's numbers. Amazing. Okay, you've got your numbers. You can print them out now to terminal. You can do 2 numbers. You can do many numbers. You can do all sorts of things. So let's bring a double into the picture, shall we? Why not? The world is our oyster. So now let's declare and initialize a double. Okay, so if I do a double, I will say that I want a type double, and then I want, another variable that's going to be a decimal. Classic naming here. Double decimal, and what will I call it? What value should I assign to it? Let's do 3.5. Okay, so I've given it a value and it's a floating point value, which means it's a decimal. Now I have only told you what the %ds are, okay, and the %ds are the ones, so you use a %d for an int, and I'm going to have a different placeholder for a double. Okay, so you need to let it know what you're placeholding space for. Okay, and we're going to use a %lf, a long float, to do a double placeholder. So I'm going to just get rid of this. Will I? Yes. Okay, let's just do a float now. So and I'll do %lf, and then I'll do a comma, and I'll tell it what I want, what variable I want in there, and my variable is called decimal, so that's what I will do in there. Okay, and let's save, and let's compile, and I've got the warning because I'm not really using anything now. And that's fine. We definitely are not using them, but I'm going to run it anyway. And so it's giving me this lovely, the value of the decimal is 3.500000. Okay. Now that looks bah, right? That doesn't look that pretty because of all of the zeros there. Do you know how does anyone know how I can perhaps reduce the number of decimal points? Yeah, so someone in the chat has said 0.1, so I can do 0.1 in front of this LF, which is saying I want to have it to 1 decimal place, okay? And let's see what it does. So I've just done a 0.1 LF. And because there might be cases where you don't want, okay, compile again. And let's run it again. And so now it's tidying it up and it's giving me 3.5 because I've said to 1 decimal place. If you have it to 2 decimal places, right, what do you think, what value do you think it's going to give us? Yeah, it's going to give us 3.50. Well done. So it's now going to give us 2 decimal places, 3.50, and so on and so forth, right? So it allows us to kind of tidy up our output if we want. Okay, should we bring a char into the picture? What do we reckon? Time for chars? Who wants a char? No one wants a char. Okay, so let's declare and initialize a char. It's going to be amazing. It's going to be char. And are you ready for this? This is the most exciting variable name ever. I'm going to call it character, which is pretty incredible. And then I'm going to assign a value. So note that the char is put in the quotation marks because that says it's going to be an ASCII value char basically, okay? So now I want to be able to print it out. Now, finally, you've got something that's going to make sense. How do you think you will do a placeholder for a char? What do you reckon? Yeah, %C. Well done. So %C is going to give us a char placeholder. And let me show you this. This is going to be exciting. And I'm actually really fed up with I'm just going to comment out some of our other variables for a second. Okay. So now let's do the character is, and I'm going to use a %C, and I'm going to say character here, and then I will demonstrate to you what I meant from before as well. So save this, let's clear this screen because it's starting to get very messy, and let's compile, and let's run it again, and so we've got it outputting out that the character is S. Okay. And what I said to you before, actually a character is also, and it's stored as an int, right? So I can do that, and then I can say, and the value is, and amazingly, I can use a %D here, okay? And my second placeholder, I also wanted to give the value of character because it's stored as an int. And what value do you think it will give? I'll bring you the ASCII table up. What value oh, that's very nice. What value do you think you'll see there for a capital S? Yeah, beautiful, 83. So it's going to give this beautiful 83 as the capital S. So let's have a look what it does. So if we do file, save, and then we will compile, and we will run, and it's giving us the character is S and the value is 83. So it's given us the character, and also it's given us the wonderful value that the character takes. So those are the three variables that we're going to do today, and we're going to go into some maths and stuff. But before that, you get to have a 5-minute break. So we always have about a 5-minute break in the middle so that you get to stretch yourself, go to the bathroom if you need to. And also I can answer any questions and catch up on it, although John and Ibi are doing an amazing job answering questions. So pop any questions in the chat, and we're going to have a 5-minute break. All right, let's come back. Okay. All right, and we're back. Okay, so I did a little poll of how everything's going because I saw some people are saying too slow, some are saying too fast. That's usually the case. I have to go with the happy majority, which says just right, but I'll try and to slow down in parts because not many people think I'm going too slow, but quite a few are thinking I'm going too fast. So I'll try and slow down where I can so we can still get through the lecture. And you can also re-watch the lecture, which sometimes helps to understand the information a little bit more, and then you can also pause it. And now that you've become familiar with some of the terminology, when you re-watch it, it's kind of better in, to understand what's going on. Okay. Let's do it. All right, so we can now print out to terminal. We now know some amazing, variables where we're sort of slowly taking off. Things are getting more exciting. So we can print out to terminal, but now we want to be able to take something from the terminal and we want to scan something in. Okay, so we want a function now that's going to read something from the terminal in the same way that printf puts out to terminal, and then we're going to be able to take in some variables so that not everything is just hard-coded in our code. We can actually take some user input as to what they want variables to be. Okay, so let's try it out. So I think I'll keep working in the same file as it looks like it's crashing. Things are going really, really well. I thought things were going too well, but no, we're back, it's back. Work in the same file, or should we get a new file? What do you reckon? Get a new file so that you can actually have some same file, new file. I shouldn't have done this. Everyone's going to have an opinion and it's going to be a disaster. Because it's going to be evenly split, and that's why things are not going to work. Amazing. Lots of people want a new file. I tend to create very long files, so maybe we will just do a new file. Let's do that. Okay. Code. Let's call it scanf.c. Okay. This program will teach you how to take input from the terminal. Yay, I think too many yays today. I really need to stop with that. Week 1, lecture 2, amazing, amazing, amazing. And let me save this file so you can see it, and then let me also make it readable by you. Okay, there it is. Beautiful. Okay. Oh, you can't see my screen. Amazing. Yes, I forgot to change screens. Transition. Beautiful transition. Smooth. Perfect. Not like you were seeing on Monday. Okay, excellent. Now we can see the screen. Now we're typing. Now we are cooking. So let's continue our cooking for this lecture. Okay, so first things first, hash include, and I'm going to include my standard input output library. And I need it because before I was outputting with printf, but now I am inputting with scanf. So a bit of this, a bit of that, a bit of everything. Okay, so my int main void, and okay, we've got our boilerplate. We are ready to go. Okay. Yeah, we're cooking, that's right. I hope it's not pizza with pineapple on it, but otherwise I'm good to go. Okay, so let's do a program that asks maybe for 2 numbers. and then we can, no, let's just go easy. Let's start with one number. We'll just take the number and then we'll print it out to show that we've got the number, okay? So first of all, I need a variable because that variable is going to take some sort of input. I'm going to store whatever I take from the terminal and put it inside that variable. So let's start working with an int. We can do other things as well so that you can see how it works, but let's start with an int because it's just easier to start with an int. Okay, so let's int and another incredible variable name, int number. And now we're going to, well, let's do a printf statement and we can say enter a number just so that it doesn't look a bit blank on our screen. Okay, so this program will, this first line here, number 10, we've declared a variable called number of type int, okay? Then here we've basically printed something out where we want them to print something out to the terminal that's going to say enter a number. And now we want to take that number from the terminal and put it inside the variable called number. So we want to assign whatever number was input into the number. I shouldn't have called it number. Now it's so confusing because I'm just saying number a lot. Okay, so I'm going to use, and that was Freudian where I just almost removed it. So I'm going to use a function called scanf, okay? And this lovely function is used to read input in, okay? So scanf, I'm going to have a bracket, I'm going to have a semicolon at the end, and inside this scanf, the format is that in double quotation marks, I'm going to say what type of thing I am looking for, okay? And in this case, because I'm playing with ints right now, I am looking for an int, okay? So I want my scanf to look for an int, and that means I tell it that it's going to be an int that's coming for it, okay? And I do that by using exactly the same format specifiers. So %d for a number, %lf for a double, and %c for a character, okay? So I've told it %d is what I'm looking for, but now I need to tell it where to put whatever it is that I'm taking from the terminal. So I'm going to do a comma. So exactly the same as we did with our printf, where we did a comma and then we did the variable name. Now, if I just do this, it's not going to work, okay? And so until week 5, I want you to trust me. And when you do scanf, you have to put the ampersand in front of the variable name, okay? Just trust me for now. Basically what it means is the address of this variable. It's helping us to locate this variable somewhere in memory and know where to place our variable number that we're going to input, okay? So trust me, you put the ampersand when you use scanf and then you name the variable name, okay? And then over here, what we're going to do, we're just going to print that number out now just to see that everything works the way that we want it to work, okay? So I'm going to use a printf just to double check that it's going on. And I'm going to say the number entered is, and I'm going to use my format specifier here to say that I want an int, and then which is the variable name that I want. I still want that variable name number, okay? So, should we try it out? So let's save it and let's compile it. And success. So it's compiled everything successfully. So now let's run it. So I'm going to run it and it's going to go to, so we've declared that and now it's gone to line 11 and it's done this command here. Enter a number. And now it's sitting here and waiting because on the next command, I'm saying for it, look for something to scan in, and that something is going to be a number, okay? So it's kind of sitting here, hanging out, it's chilling, it's waiting for me to enter a number. So I'm going to enter a number and I'm going to press enter, okay? As soon as I entered that number, I press enter, it stored it into this variable and then it moved on over here where it printed it out. the number entered is whatever it was and whatever is sitting inside that variable, okay? How's that? We're not going to learn pointers now. Obviously, that's a ridiculous suggestion, whoever said that. You're going to learn pointers in week 5, and that's when you will actually understand what that ampersand actually means. Okay, what a great question in the chat. What happens when you don't type a number though? Do you know what the best way to try it out is? To just do it. Shall we try it out? What happens if I put in a G? What do you reckon is going to happen? Will we have success? What do you reckon? Okay, a lot of, a lot of, and we have a runtime error, uninitialized variable accessed. Now that error occurred on our printf, okay, because we tried to access whatever was in number and it was not what I was looking for, right? So if we wanted to scan in a character, and characters are, no, I don't want to do characters yet, because characters are, there's a little bit of a trick to characters. So give me a second till we get to characters. We're not going to do characters yet. Okay, and I'm trying to like keep the difficulty low still, because if I start to explain the scanf buffer, I feel like I'll lose half of this lecture. So for now, just see that it doesn't work, and we will talk about why it doesn't work in a little bit, when you have a little bit more information to be able to understand what's going on, okay? Okay, so we've scanned in, we can scan in a number, things are going great, things are amazing, super exciting. What if we want to do a double, and we want to read in a double, okay? So let's declare a double, just so that we can see what happens then. So I'm going to do the same thing. And then what I'm going to do is I'm going to use scanf, and I'm going to, what do you think is going to be the placeholder if I want to scan in a decimal? Yeah, %LF. So it's all the same, right? Across the board. And I'm going to scan it into decimal. So don't forget the ampersand. And I'm going to say I want it to go into this lovely decimal thing. And let's print out and we're going to placehold that, and we're going to ask it for the variable decimal, okay? Who decided to make you learn C? I can promise you it will come good. You will appreciate it. Even though you'll hate it for a little bit, I promise you will appreciate it, because every other language from now on is going to be so much easier to learn. Okay, let's compile it and let's run it again. So again, it's reading up to number 11, line 11 here, and it's saying enter a number. I'm going to enter 13, press enter, and it's scanned it in somewhere in there. It's put it inside the number variable. Then we're going to go to a double, and we're going to go to line 16 here where it says enter a decimal value, which is what it's doing here. So now I'm going to enter some sort of decimal value. I'm going to press enter, and it's going to release it all to me through these two printf statements. So the first one is going to give me whatever is stored inside number, which is 13. And the second one is going to give me the decimal that is stored inside the decimal variable, which is 3.567. Amazing, right? Okay, that's great. Things are going well for us. And that's because we haven't scanned in some characters yet. So let's scan in a character now. How does that sound? Does that sound good? Is everyone still going all right? No, there's no way there's a fellow Haskell enjoyer in chat. There's no way there's ever going to be a fellow Haskell person. Did you know that was my first computing language, Haskell, that I learned formally? Okay, still clinging on. Okay, amazing. Okay, I'm going to scan in a character and then I'll go back and just quickly talk about it again, okay? When are you learning Rust? When you get much better at programming and then you can choose a higher, more advanced course that's teaching Rust. That's when you're learning Rust. Okay. And C is used a lot still. Okay, not like as a, I do not have to defend C. C defends itself. Okay, so we've got our decimals here. Let me just do a little comment for those that will go through. And then let's do a char. Okay, and let's declare a variable called character of type char. So I'm going to declare, I'm going to say I want a char, and I'm going to call it character because imagination is amazing. And then I'm going to ask for a character. Enter a character. And then I'm going to scan in the character. So by now you figured out it's all the same placeholders, all the same format specifiers. So I'm going to %C for a character. And I'm going to put it inside character. And let's see what happens. Does everyone think we will be very successful here? What do we think? Do we think success or not success? And I'm going to print out here just so that we can see how successful we were. There's nothing like a humble brag. %C, and I'm going to do a new line and oh, someone's tried it and it didn't work. You're way ahead of me. Okay, but I'm going to run it anyway. Let's compile it. Let's run it. Enter a number. I'm going to use the same numbers, 13, 5. Oh, that's not a number. That's some sort of abomination. And then I press enter and somehow it all skipped everything. It says enter a character, but it skipped all of that and it entered all of that. Can you tell me what you think happened? What do you reckon happened here? And notice here, I did that, and here I've got this weird something happening over here as well, which is going to give away what's going on. What do we reckon? I entered something as a character. Yes, someone's got it. New line is a character. If you remember on the ASCII table, we had that beautiful line feed at 10, and it was a character. So when I entered my decimal of 5.67 and pressed enter, it read that as the character. And it perfectly went on. Here it is. It outputted that my character is a new line. It gave me a new line. Things are fantastic. Now, who knows what I can do, okay, because this can get quite annoying, I would imagine, a few things. Who knows what I can potentially do here to alleviate this? How can I make it skip some white space? What do we reckon we could do? I don't know if anyone knows. Obviously, we could... someone might not know. Someone's wanting to use getchar. Oh my God. Too much. We're not up to getchar. Oh, we're so close. Okay. What happens, do you reckon, if I put a space before the %C? Do you think that will help matters a little bit? Let's try it out. Let's run it. I hope you're all just holding on to your chairs. Are you holding on to your chairs? Oh, I mean, unless you are not sitting down, then don't hold on to a chair. That could just get awkward. So you can kind of tell scanf to ignore preceding white space by doing a space in front of the %C, okay? And what it will do is it will just ignore white space and it will wait for a character, right? Okay, amazing. So someone's asked to read it, enter, okay, didn't return which was, so when it pressed enter, my space here is telling it ignore any like new lines and white spaces. And then I'm also at a stand-up desk, so I couldn't hold on to my chair. Well, I could, but I'd have to roll it back. Okay. So, amazing. Like, mind blown, right? Okay, how do we feel about variables? Ibby, could you please do a little poll how we feel about variables? Because then I can see it without the chat being flooded of whether we love variables, we feel like we're lost, we want to go over them again, or we're ready to move on. We're ready to leave this behind and move on. You hate variables? No. You cannot hate variables. They vary. Ibby's taking so long to do this poll. Everyone is just telling me how they feel. Okay, so basically entering a space before %C works because it's telling it to ignore preceding white space. Ibby, how slow are you typing? I'm joking. Ibby's amazing. Okay, good, bad, need more time. Maybe those are great categories. I'm not sure what need more time is. Need more time in this lecture or need more time to reflect yourself? Oh, sorry, we had to switch to 1511 account. Sorry. Okay. Preceding white space is any white space. So spaces, new lines, anything that's, I want to say rubbish, but it's not really rubbish. But anything that's like spaces, new lines, it will ignore them until it gets to something that's more meaty. Okay. Okay, oh, we haven't even gotten to maths. Okay, I'm going to push on a little bit because people feel like it's good. Then you might need some time to reflect. And then at the beginning of the next lecture, we'll go over it again. So don't worry. Actually, Angela will go over it again because I will be in Pittsburgh. Okay, let's do it. Okay, what happens, all of these variables, not that we varied them, but I guess here they could take variable values because we got to enter them as a user. Yes, there is a Kahoot next week. I've prepared a whole bunch of Kahoots. Where's Pittsburgh? In America. Okay. What happens if I want a variable that does not change values throughout the whole of my program? And what kind of variable is an example of that? I mean, pi doesn't change value. Yeah, I want some sort of constant, okay? So I want something that is going to stay constant throughout the whole thing. So like a variable, but doesn't change. We do not want you to use global constants in 1511. We're going to hash define and do some beautiful magic numbers here. Okay, so after your hash include, you're going to hash some more things and you're going to hash define, okay? So you use the keyword hash define, and what we get is a hash define, and we're going to define a constant, okay? So let's just keep with the theme, meaning of life. So notice here my constants, well, for once I use snake case, which you should be very pleased with that. But also I made no spelling mistakes, which is another success. But also you'll notice that all of it is in capital letters, okay? So our hash defines, or our magic numbers, the constants, we do them in capital letters always. And because, so we're doing this because when we're reading through code, when a human is reading through code, we want to be able to see straight away that a constant has been used, right? Because it allows us to see if there's any mistakes, and in debugging. So having it all in capital letters makes it for much better flow and much better readability, much better style. So all in capital letters. And then what I do is I give it a little value, and I've given it a little value, 42. And that means that anywhere you see meaning of life now, it's not like it's assigning the value to it, but it's like copy pasting it. So anywhere in my function that I will say meaning of life, it's just going to replace it with this 42. And don't worry, we will talk more about that. And yes, we keep it very simple in 1511 to start with. And then you will go to more advanced courses. You'll be able to do more advanced things, don't worry. But we start with the building blocks, okay? So, amazing, okay? We've got our a constant, and we've defined it, and now what should we do with it? I can use it somewhere. We can just print it out. How does that sound? Let's print out a constant. Okay, so we're printing out our constant. Let's see what it does. And don't worry, we will do more constants. It's just to let you know that there is something that I don't know why I did it on this program, that where I now will have to do a whole bunch of things. And you can see over here, it's printed out that constant for me. So it saw this meaning of life and it replaced it by that 42. So that's a constant, and we will talk more about constant. Don't worry, don't worry. Okay, so yeah, okay. So we've got constants. We'll talk about scanf a little bit more. And I think we should do some maths. How do we feel about moving on to maths? Well, it was not too bad on the poll. Struggling. No equals in, we don't need any equals in your hash defines, okay? It's just the name and then the number. And it's because it's just going to basically look it up and replace it. It's like find and replace. It's kind of like that. It's doing that. That's a very basic way to look at it. Okay. Okay, lots of people, okay. Why can't we define the variable inside main? You can, but some variables don't ever change. So you will define it as you know, as a constant, because it can be used, if I define it outside of main, it can be used in the main or in any other functions that I have as well. And it never changes. You can, you know, you can hash define pi as well, and you can give it 3.14, right? Then you've got your pi. Okay. We will talk more about these. Don't worry. Every time we'll approach them, we'll talk more about them. No, we're going to do maths now. Don't worry. Maths will be piece of cake. let's do a new file for maths. And then we can go back and talk about the things as well that maybe people are not quite, every time, people are not quite sure about. Okay, let's do it. Okay, guess what? We've got all the maths that we have in life to use in C. Just some weird things going on, that's all. So we can use plus in C, we can use minus in C, we can use multiply in C, we can use divide in C. Divide is not that pretty. We can use brackets in C. And we also have the modulus to be used in C. So we have a few things that are just blowing your mind, hopefully. Okay, so let's do these simple things, okay? Let's try it out. So I'm going to just do two variables because number one, and I'm going to do int number 2. Okay, and I'm maybe going to have somewhere to store things into, so I'll just have this int result, right? And that's just to show you what's going on. Okay, so what I can do is I can actually do some maths. I can do, why did I choose such ridiculously long variables? Okay, so that for me is going to, and I'll show you as well how to do it shorter and punchier. Okay, so that's just to show you the plus, okay? I could use num1 and num2. I really could. Or I could just have x and y and call it a day. But for some reason, I'm going to have x and y and we're going to call it a day. How's that? Okay, so we've done some adding. Let's see it. Let me give you access to the file, actually. Let's clear this window. And speaking very good today. Let's compile. And let's run it. And the result is 53. Because 13 plus 40 is equal to 53. Now over here, I've got a lot of steps happening, don't I? What I can do is, let's say I don't have this and I don't have this. My format I don't know if I'm now going over the top. Just let me know in the chat if I've gone too far. But my format specifier says here, it wants a %d. So I could even do x plus y in here because the result of this is going to be a %d. Yeah? So I can also do it like that. I don't have to do it as separate lines if I don't want to. Whether it's good readability or not, that's another story, right? So someone just said I'm going too fast. I'll go. And why does it not print 13 plus 40? Because I haven't told it to print 13 plus 40. I'm only telling it to print the result is, and then I'm getting it a format specifier, and I'm putting in the x plus y. Or if we go back to this way, I'm telling it to print out result, okay? So basically what it's doing in here is it's declaring a variable of type x, and it's initializing with 13. So declare and initialize variable x with 13. Then it's doing the same thing but for a different variable on the next line. So it's declaring and initializing variable y with 40. Then on this line, it's just simply declaring a variable called result. And it's because here I'm going to store something in that variable. So here we're assigning the sum of x and y to variable result. And then here we're printing out what actually happened. Okay, so here we're just printing out what is sitting inside that variable result so that we can see what's going on. How's that? Does that feel a bit better? And you can, yes, you can also do, instead of this, you can declare and initialize it all at the same time as well. So in this one, I'm declaring and assigning all at the same time. So I've declared the variable and also assigned to it at exactly the same time. Okay, so that's addition. What happens if we do subtraction? Okay, so let's change that for a subtract symbol. Save it and let's compile it again. And let's run it again. And it's giving me minus 27, which is the result of 13 take away 40. Yeah, so that seems okay. No problem. That's all good. All right, should we try multiplication? Let's do multiplication. So I've changed the sign to a multiply. I'll compile it again. And then I'll run it again, and the result is 520, which is correct. Yep, that is correct. Excellent. Amazing. Okay, great. So we've reached the point where we're up to this beautiful division symbol. Okay, what do you think if I divide is going to give me? What do we think? Okay, few people have some, so it will work. Yeah, why do you think it gave me 0? So what I'm doing here is x divided by y, 13 divided by 40. Well, I mean, it is a number, but it does give me a float, not an int, if I were to do it. If this over here, okay, because 13 divided by 40 is 0, remainder 13. But if I make this a double, okay, and I do the same thing here, do you think it will now provide me a result? What do you think? Yes or no? Okay, so lots of people think yes. Okay. Point of no return is coming. My result is a double, but my two things that I'm dividing are both ints. Here we go. Nope. And the reason for that is because my result is a, thanks CB, one of my favorite things to do, sorry. And it's because both of these are ints, right? So it's done an int operation. An int divided by an int is an int. Now what happens here, okay, let's reassess this situation. We'll go back to an int, and here we'll go back to an int. What do you think it's going to give me if I go the opposite way? Y divided by x. What do you reckon that will give me? Yes. Very good. Okay, the result is 3. It just gave me the full number, but not the decimals leading up to it, right? Not the decimals associated with it. Okay, so we've talked a lot about int divided by an int, and then we get an int, okay? So even though I declared the result a float, I still get an int. I've just made it look like a float by giving it lots of zeros. So why don't we try changing one of these to a double and see what happens when we divide and I'll go back to x on y just for fun, but so let's see what happens when we divide a double by an int. Let's compile again. Oh, well, not a lot is going to happen, but okay. Why is not a lot going to happen? Because let me convert that to. All right, so now I've got a double divided by an int. And let's see if it's going to give me something prettier. Okay, so now it's going to give me the actual result, okay? Because I've divided a double by an int. And that's some of the quirks in C kind of have to do with that. Now, who knows what modulus is? Who knows what the percent is, the modulus? And I do recommend sometimes in the lecture we don't have enough time to kind of try all the permutations and combinations. Go home and then take this code and play around with it. You know, don't be worried about breaking it. Don't be worried about making mistakes. It's really, you learn the most from the errors that you see on the compiler and from the errors that you see when it's, you know, when it kind of shows up on what it's doing. Yeah. No, don't worry. I'm never doing permutations and combinations. I hate that topic. I think it's bad. Okay, remainder. Yes. So a modulus is a remainder. So let's do a modulus here to try it out. So, and I'm just going to change everything back to ints. And then we're going to play around a bit more. So what do you think is going to be the result that's going to be printed out in this case? Okay, so just the error is because I changed my result type to int, but I've left the format specifier as %lf, so they don't match up because I'm saying, okay, I want the result in here, it's an int, but then I was asking it to save space for a %lf. So that's why that error has occurred. So let's compile again and let's run it. And someone's saying 0 or 13, 13, 0. 13, because when you do 13 divided by 40, the result is 0, remainder 13. So you get your remainders. And that modulus is very, very useful when you need to find even and odd numbers as well as other things, but the even and odds, super useful. Okay, amazing. This is, so, and brackets. You can use brackets to kind of have precedence the same way as you would have in maths, okay? So it's exactly the same in that way. Okay, someone wants me to swap them around. What happens if I do y divided by x? Not divided by, modulus x. So what do you think is going to be the answer in this case? 40 divided by 13. And then what's going to be the remainder? 1. Amazing. Look at everyone. You got it. Yay. Okay, now I'm going to blow your minds because we've just learned that chars, I'm going to do one more thing, okay? I promise, and then after that I'll take a little break and we'll do something, have a little chat about issues. Just one more little thing, okay, to really leave you for the week feeling bloated of information, okay? And I hope that it hasn't been too bad as an introduction to see that you're not feeling overwhelmed. But don't worry, you still have your labs and you still have your tutes where you will go over everything again. So please don't feel overwhelmed. You start in the lecture, you move on to the tute to kind of get the concepts more solid in your mind, and then you go to the lab to practice those concepts, okay? So don't worry. Okay, I'm going to blow your minds and I'm going to show you that you can also do maths with chars, because chars are really ints. So let's say I've got a char and it's called letter, and I'm going to say it's A. Actually, let's go to S because we know what S is. If we remember, it's 83. And so, and I might have a variable next letter. I'm really struggling to press equals today. I can do letter plus 1. And what do you think it's going to give me if I do letter plus 1? What do we reckon? 84. Yeah, well done. So as an int, it's going to give me 84, but as an letter, it's going to give me the following letter. It's going to give me T. So if I do printf, just to show you, and I'm going to do, okay, letter is %C, and next letter, and what I'm going to do is I'm going to do next letter is, I'm going to do it as a %C, and I'm going to do it as a %D, so you can see that it does both the number and the actual letter itself. So letter, next letter, this is now really bad style, next letter, that's okay, we'll just do it quickly. Do as I say, not as I do, there you go. Okay, so let's compile it, and let's run it, and let's see, and also could have been nice to just have some new lines. Anyway, the letter is S, the next letter is T, and it's 84 because the letter S is 83. So 83 plus 1 is 84. And then this random, the result is 1, is from this line over here, which is doing the maths that we were doing with modulus. Okay, I'm just gonna and please don't worry, again, even if you didn't understand everything in this lecture, even if you feel overwhelmed, you will go over things again. We do fill you up with information in the lecture, but then you do get to make it more solid, and you also get to practice it in your labs. So please don't stress. And I will also rehash things in the next lecture and the following lecture. I always like to rehash a little bit. Okay, how are we feeling? How are we feeling? Let's do a poll. How are we feeling after this first lecture? I'll do a poll, don't worry, Ibi. And then we're going to talk about a few fun things. Okay, there we go. Let's start with this. And now let's talk about a few fun things. What happens in C when things go kaboom? Okay, what happens when things go kaboom? And things do go kaboom when we have some integer overflows or underflows. So we've got this lovely aeroplane. It had to be rebooted every 248 days. And that's because it had a beautiful integer overflow, because 248 days is 2 to the 31 hundredths of a second. So that's a bit unfortunate. Someone did some very bad coding in there, and that could have been complete disaster, right? Because it's on a plane. It's a real, it's a real problem there. If we add two large ints together, we might go over the maximum value possible, and what happens is that it ends up negative, right? And we have had an explosion for that as well, and it's really a very big problem when that happens. And it can also be less destructive example, right? So on a less destructive example, Gangnam Style reached the maximum counter that you could have for YouTube, and that's because it reached the limit of the int, right? So it's not that dangerous, but quite fun. Finally, that got broken. What we said before, ints are not always 32 bits, okay? That can vary depending on the architecture and what you're using. So don't ever assume that it's going to be 32 bits. We can't precisely encode something simple like 1 out of 3, and if we divide 1 by 3, we'll get an approximation, and then if we kind of keep going, it can really compound and become quite a big problem, right? So there's no such thing as infinite precision. Okay, I think we did all of this lovely stuff, and I've talked about here. So if either of the numbers in the division are doubles, the result will be a double, which is what we did see. If both the numbers are ints, the result will be an int, which is also what we did see. And ints will always drop whatever fraction exists, so they won't round up, right? So they will always just give you the whole number of that operation. Okay, a little bit of feedback if you like from the lecture. Was it going too fast? Was it going too slow? Was it going just right? And then after that, we are done. We are cooked. It's 5 minutes to. Hopefully you don't have a maths lecture now, but if you do, good luck. May the force be with you. What an ugly Tuesday for you, 4 hours of lectures. But thank you so much, and I'll see you guys in a few weeks because I will be away for the next few weeks. Good luck.